Today we are going to discuss about limitations of linear queue. First of all, we should know what is a queue, how to represent a queue using array, what are different operations of queue, and what are the limitations of linear queue. First one is what is a queue? Queue is a waiting line, like a line of people waiting to purchase tickets or a line of people waiting to use ATM. The first person who entered into the queue will get served first. So queue is called a first in first out list. The first person who entered will get served first. The new people will going to join at rear end. So it contains two ends, rear end and front end. New people will join at rear end and the front end, the person who is at front will get served first. Then in the terms of computer science, queue is an ordered collection of data items into which elements are inserted from rear end and elements are deleted from the front end. A queue can be represented as a structure. It is a data structure. It can be represented as a structure which contains three members, that is array and position of front and position of rear. See here, Q is a structure which is having an array and a variable called front and a variable called rear. Entry of max q. Entry of max q means here max q is a constant here, max q 5, indicating that a maximum number of elements that can be placed in the queue are 5. Then entry of max q, where entry is name of the array, name of the array. So if this is the array entry, which can store a 5 elements, and it is having another two variables, front and rear, where front holds position of first element and rear holds position of last element. See here, assume that there are 5 elements and 4 elements are have been already filled. First element is at location 0 and last element is at location 3. So front is 0, rear is 3. Front is 0, rear is 3. The collection of array front rear is said to be queue. Now queue is a data structure which is having an array, that is storage of some data items, and the procedure is we insert element at rear position and we delete element from front position, so we maintain the positions of front and rear always. So for this, the collection of entry front rear is called queue, is called queue. Then how to insert elements into the, what are the different operations? Insert and delete. Insert, delete. Insert, delete. Insert, we can insert elements from rear end and we can delete element from front end. You wanted to insert one more element, that element can be inserted in the next position 4 and this becomes rear. You wanted to delete an element, front position is 0 and the element at 0 position will be deleted. So we can insert elements and we can delete elements. The element that we wanted to insert can be inserted at rear end. How to insert? Let me explain. So there is a function called insert, insert q comma x, where q, it is of type q type. Asterisk q means it is a pointer. It is going to be modified. That's why whenever we call a function, we pass a reference parameter. The variable which holds address of another variable is a pointer. So q is of type q type, which is having three members: entry, front, rear. Then if q rear is max q minus 1 means this is the condition of q full. If q is full, not possible to insert any elements, error message will be displayed. If q is not full, element can be inserted, that is rear is increased and in the place of rear new element is placed. So here this is the condition of q full. Rear reached its maximum position. So here see, there is a possibility of storing 5 elements. If we store all 5 elements, the fifth element will be placed at location 4. So this becomes rear. If rear is 4, not possible to insert elements, because rear here in this particular example, rear is only 3. It is not equal to max q minus 1. So there is a possibility of adding one more element here. So one more element can be placed in rear position, that is rear is 3, 3 plus 1 4. In the place of 4, new element can be placed. Then here, let us have an example inserting elements into a queue. So this is the function we have already seen, where initially we assume that there is an empty queue which can store maximum of 5 elements. So queue, there is a queue. Queue can store 5 elements. Initially it is empty. Empty means front is 0, rear is minus 1. Front is 0, rear is minus 1. Array does not contain any values. Array can store 5 elements. And front is 0, rear is minus 1 is the empty condition. There are no elements in the array. Then try to insert an element. Insert q comma 10. Insert q comma 10, where we are trying to insert 10 into the empty queue. Rear is rear plus 1. Rear is already minus 1. Minus 1 plus 1 0. In the place of 0, 10 is placed. Now say front is 0, rear is 0. Now again you wanted to insert one more element at this stage. So 20 will be inserted in the next location of rear. When rear is not reached its maximum position, rear is not reached its maximum position, rear is 0. So rear is increased by 1, rear is 0, 0 plus 1, 1. 1 first position is filled with the value. Again you wanted to insert one more element. Insert q comma 30. 30 is going to be inserted in the next position of rear. Already rear is 1. The next position means 2. 2 is there, right? So 30 is placed. The same fashion 40 is placed. The same fashion 50 is placed. Now, if you try to insert another element where Q is already full, rear reached its maximum position. Once rear reached its maximum position, if you attempt to insert an element, it displays an error message. See, the function is if rear is max q minus 1. If rear is max q minus 1, where max q is total number of elements, or the total capacity of the queue. So total capacity is 5. 5 minus 1, 4. 4 is the last position of last element. So rear is already pointing to 4. So error message is displayed. Instead of increasing rear and placing new value at rear position, it displays an error message. So it is error queue overflow, because queue is already full. The new element you are attempting to insert will overflow. Okay. So this is queue full condition. Once queue is full, you can delete elements, right now. So if you wanted to delete element, you can delete element from front end. So 0, front is 0, front is 0, rear is 4. Deletion means we can delete elements from front position. So 0, front is 0, 0 position element is going to be deleted. So apply delete function. So front is 0 and the element that is there at location 0 is going to be deleted, and front will be increased by 1. So front is pointing to 1 now. So front is 1, rear is 4. Again you wanted to delete. Front element will be removed and front will be moved to next location. Front is 1, first element is 20, 20 is removed, so that front moves to next location. See here, front is 2, rear is 4. Now attempt to insert an element now. Insert q comma 60. Insert function tries to insert an element into the queue. Insert function tries to insert an element into the queue at rear end. Every time you try to insert, the element will be inserted at rear end. Now, at this particular position, front is 2, rear is 3, you are attempting to insert an element, then it checks if queue is full. If queue is full, not possible to insert. Insert else. Rear is increased and entry of rear is x. See here, rear is 4. Q full condition is rear equal to max q minus 1. Rear is already equal to max q minus 1. Rear is 4. Max q is 5. Rear is 4. So rear is already reached. Rear is 4. Max q minus 1 is 4. So it is equal. So not possible to insert. Error message will be displayed. Even though there is some space. See here. Even though the array can store 5 elements, only 3 elements are there. There is space for 2 more elements, right? Only 3 elements have been entered into the list. There is space for 2 elements is vacant. Still, it is not possible to insert element into the queue because rear is already reached its maximum position. Even though there is space, it is not allowing you to insert an element into the queue. So this is the disadvantage of linear queue. This is the disadvantage, or you may say limitation. Disadvantage or limitation of the linear queue. This disadvantage we can overcome if we consider this as a circular queue. Suppose if we consider this as a circular queue, suppose a circular queue means the position, zeroth position and last position are adjacent. If they are adjacent, and next position automatically, if it is there at 4, automatically it moves to next position, adjacent position may be 0. So that I will discuss in next class.